Hi, my name is Vivian, and my project is about the living quality assessment of Irvine, California. There will be a total of 4 aspects that will be considered as a criteria of good life quality, and they are proximity to schools and colleges, distance from highways, average household income, and proximity to toxic release sites. The first aspect is proximity to schools and colleges. To calculate the driving distance from the school to the surrounding areas, network analysis is operated towards the OpenStreetMap data of Irvine, California to calculate the surface areas of these schools and colleges. OSM file of Irvine is loaded onto ArcGIS to create surface area polygons. I created a total of 3 surface area polygons, one within 1 minute driving distance, one within 3 minute driving distance, and one within 5 minute driving distance. After creating a new attribute field in the Orange County block group shapefile, naming school score, I use select by location to select block groups that intersect with the surface areas and use the field calculator to assign scores to the block groups. Areas closer to schools and colleges will be given a higher score. Any block groups that intersect with the pink polygon, which is surface area within 1 minute driving distance, is given 20 points that will be added towards the final living quality score. Any block groups that intersect with the purple polygon, which is surface area within 3 minute driving distance, is given 15 points that will be added towards the final living quality score. Block groups that intersect with the green polygon, which is surface area within 5 minute distance, are given 10 points. Block groups that are out of the 5 minute surface area are given 5 points. The second aspect is distance from highways. The highways are filtered down to only the Class 1 highways because I only wanted to incorporate the major highways that will have higher traffic volume. To calculate the distance from the highways to surrounding areas, buffer analysis is used. I created a total of 3 dissolved buffers, a 0.5 mile, 1 mile, and 2 mile buffer. I also use select by location to select block groups that intersect with the buffers, and use the field calculator to assign scores to the block groups. A separate attribute field called highway score is created in the block group shapefile to store the assigned score. Areas that are closer to highways will be given lower scores. Block groups that intersect with the 0.5 mile buffer that is shown in green will be given 5 points that will count towards the final living quality score. Any block groups that intersect with the 1 mile buffer that is shown in pink will be given 15 points. Block groups that intersect with the 2 mile buffer that is shown in the light blue will be given 25 points. Areas that are not within any of the present buffers are given 30 points. The third aspect is average household income. The block groups are joined with Census Bureau income data table through GeoID. The attribute field B1901E1 indicates the average household income field. I created a new attribute field called Wealth Score in the block group shapefile. Then I use select by attribute to select block groups with different levels of income and use the field calculator to assign scores to them. Areas that have higher average household income will be given higher scores of living quality. The map shown here is categorized with the natural breaks classification, but the scores are given in a more general rating. Areas with average household income with 0 to 500 will be given 10 points. Block groups with the average household income within 500 to 1,000 will be given 15 points. Block groups with income within 1,000 to 1,500 will be given 20 points. Any block groups with income between 1,500 and 2,000 will be given 25 points. Block groups with average household income between 2,000 and 2,500 will be given 30 points. Block groups with average household income within 2,500 to 3,000 will be given 35 points. Any block groups with average household income between 3,000 and 3,624 will be given 40 points. The fourth aspect is proximity to toxic release sites. To calculate the proximity of locations to the closest toxic release site, the Euclidean distance tool is used. The tool calculates the distance between each cell to its closest toxic release site. The reclassification tool assigns scores to each cell according to its proximity to the toxic sites. The closer the area is to the sites, the lower the score it will get. The map on the left categorizes with the natural breaks classification, but the scores will be given in a more general rating. Cells with Euclidean distance between 0 and 0.05 are given 0 points. Cells with distance between 0.05 and 0.1 are given 10 points. Cells with distance within 0.1 to 0.15 are given 25 points. Cells with distance between 0.15 and 0.2 are given 50 points. Then I used the zonal statistics as table tool to produce the mean of the scores of each cell within the individual block groups and create a general score of the block. I joined the table with the block groups shapefile through GeoID to give the block groups an additional attribute field that indicates the score of proximity to toxic release sites. Finally, for the final map of living quality index, all the scores of the block groups from the 4 criteria are added together to create a final living quality score. This is done so by creating a separate attribute field called final score and use the field calculator to assign the values by adding all 4 scores from the 4 criteria together. The final map provides a good index of living quality. The analysis is at the smallest geographic unit of block groups to provide more detailed variation of living condition within a city. This map can work as a good guideline for people who are choosing Irvine to move to but don't know exactly which area within Irvine is more suitable to live. Thank you.